What are finite and infinite sets? Finite and infinite sets. So, a set which is empty, a set which is empty, then it does not have any element, or consists of a definite number of elements is called finite set. Otherwise, we call it a infinite set. So a set which is empty or consists a definite number of elements is called a finite set. Otherwise, we will call it an infinite set. Or if your set contains infinite elements, then your set will be infinite set. So let's take a look of our previous example. Now this set, the set A contains 5 elements. So it is a definite number of elements. So the set A is finite. The set B again 6 elements, finite. The set C, even though we need to count the hair in our head, the number is big, but still it's a finite number. So this set will also be finite. Now the set of natural number, the set of integers, the set of real number, or the set of rational number, they all are infinite sets. And empty set is also. Let's see this example 6 on your page 7. Example 6 on page 7 of your NCERT class 11 book. So, state which of the following sets are finite or infinite. So we simply need to tell if the set is finite or not. So, suppose we have this set. The set is x such that x belongs to n, that is x is a natural number, and x minus 1, x minus 2 is equal to 0. So, it's very easy. X minus 1, x minus 2 is equal to 0. This gives us what? X is equal to 1 and x is equal to 2. And they both are natural numbers. So this set will be 1, 2. It contains 2 elements and therefore this is a finite set. Now let's see the second example. X such that x is a natural number and x square is equal to 4. Now, when we solve this set, if you solve just this equation, x square is equal to 4, then we will get x is equal to plus minus 2. But there is one more condition, that x should be a natural number. So, since x is equal to minus 2 does not belong to n, it is not a natural number, only x is equal to 2 will be in the set. So again, this set contains only a single element and therefore this is a finite set. Now let's see the third part. X such that x belongs to n and 2x minus 1 is equal to 0. So if you solve this equation, you will get 2x is equal to 1 and therefore x is equal to half, which is not a natural number. So it does not belong to n, right? And therefore, there is no x which is natural number and which satisfies this equation 2x minus 1 is equal to 0. So this means that this is an empty set. You can represent it by this or by this. Okay. So empty set is also a finite set. So therefore this is a finite set. Let's see the next example. The set is X such that X is a natural number and X is odd. So we know what this set is. This is the set of all odd natural numbers. So this is 1, 3, 5, 7, and so on. So this is a never ending set. You can always find the next odd number, right? So this is a infinite set because it contains infinite number of elements. Okay. Hope this clears your finite and infinite set. Now let's see what are equal sets. Now let's see what are equal sets. So suppose we have given two sets, A and B. If every element of A is also element of B, if every element of A is also element of set B, and if every element of B is also an element of set A, then we say that set A and set B are equal. It simply means that the two sets should have exactly same element. That two sets should have exactly same elements. Then we will say that, okay, they are equal sets. Let's see some example. So suppose we have this. Suppose we have A is equal to 1, 2, 3 and B is equal to 3, 2, 1. Okay. Now, the element in A are 1, 2 and 3. The element in B are 3, 2, 1. So let's see if every element of A is the element of B or not. So element of A are 1. 1 is here. The element of B is 2. 2 is here. The element of A is 3. And 3 is also in B. Similarly, the element of B3 is in the set A. 2 is also in A and 1 is also in A. So the set have exactly same element. Even though the order is different, we have written it differently, 1, 2, 3, and this we have written 3, 2, 1. But since they have exactly same element, it means that they are equal. Now let's consider another example. Suppose we have this set, A is equal to 1, 2 and B is equal to 1, 2, 3. Now, every element of our set A, so 1 is in A, 1 is in B. 2 is in A, 2 is also in B. So every element of the set A is the element of the set B. Now let's see what about B. So 1 is in B, 1 is in A. 2 is in B, 2 is in A. But 3 is in B, 3 is not in A. So 3 belongs to B, but 3 does not belong to B. So this means that A is not equal to B. So if the sets have different element or there is an element which belongs to one set but not to the other, we will say that the sets are not equal and we will represent it as this. A is not equal to B. Now let's take another example. Suppose we have this. A is equal to 1, 2, 3 and B is equal to A, B, C. Again, even though both have three elements, the elements are different and therefore the sets are not equal. Now, suppose we have this set A is equal to X such that X is a natural number and it lies between 1 and 2. And this set B is equal to X such that X is a natural number and 2x minus 1 is equal to 0. Or C is simply the set of all unicorns in the world. So this set is empty. We have already discussed. This set is empty. We have already discussed. And as far as we know, there is no unicorn in the world. So therefore, this is also empty. So all these sets, even though they are written differently, they are equal. So all empty sets are equal to each other because they are simply the same set. Now let's see example 7. Let's see some example of your NCERT. Suppose we have A is equal to 1, 2, 3, 4 and B is equal to 3, 1, 4, 2. Now it is clear that all the elements of sets A 1, 2, 3, 4 exist in the set B and all the elements of set B 3, 1, 2, 4 in the set A. So this means that A is equal to B. Similarly, let's take another example. Suppose we have a set A such that A is the set of prime number less than 6 and B is the set of prime factor of 30. So if we solve this set of prime number less than 6 are what? 1 is not a prime number, 2 is a prime number, 3 is a prime number, 4 is not a prime number, 5 is a prime number, and then that's it. Because after that, the number will not be less than 6. Now, the set of prime factor of 30. So, the factors of 30 are 2 into 3 into 5, right? 2 into 3 into 5. And all these three are prime. So, this is the set. Now, even though we have written it differently, the set of prime number less than 6 or the set of prime factor of 30, since we are getting same number of element in each set, this shows that your A is equal to B. A is equal to 1, 2, 3 and B is equal to 2, 2, 1, 3, 3. Even though this is not a correct method to write a set because in set we usually don't repeat the elements. So this actually we should have write it like 2, 1, 3. Okay. So technically these two sets are equal. Okay. Now let's see the example. Example 7 of your NCERT book at page 8. Find the pair of equal sets, if any, and also give the reason. So suppose we have these sets. A is equal to 0 and B is equal to X such that X is greater than 15 and x is less than 5. C is equal to x such that x minus 5 is equal to 0. D is equal to x such that x square is equal to 25. And E is equal to x such that x is an integral positive root of the equation x square minus 2x minus 15 is equal to 0. So, we need to see which of these sets are equal to each other. Okay, so let's write these sets in the tabular form if it is. So, this set A is 0, so it is clear. Now, B is, so let's write A is equal to 0. Now, B is the set that contains all numbers which are greater than 15 and less than 5. So, of course, it is not possible. If a number is less than 5, obviously it cannot be greater than 15. And if it is greater than 15, it cannot be less than 5. So, this means that the set B is empty set. As for the set C, x such that x minus 5 is equal to 0. So, this means x is 5. So, set C is simply 5. For the set D, D is equal to x such that x square is equal to 25. If we solve this, we will get x as minus 5 and 5. Now, it is not written that if it is natural number, integer, or a real number or rational. So, we will simply just take them as number, that x is a number and x square is 25. So, we will take both the number. So, what will we get? We will get D as minus 5 and 5. Till now, no sets are equal to each other. Now, let's see this set. Set E is equal to x such that x is an integral positive root of the equation. So, this means that we need to solve this equation. X square minus 2x minus 15 is equal to 0. So, so for this, we will use this formula. If we have given this equation, ax square plus bx plus c is equal to 0, the root of this equation is given by x is equal to minus b plus minus square root of b square minus 4ac divided by 2a. If we compare this equation, x square minus 2x minus 15 is equal to 0 with this, we will get that a is 1, b is minus 2, and c is minus 15. On substituting the value in here, we will get x is equal to minus b, so 2, plus minus b square, so minus 2 square, minus 4ac, so 4 into a into minus 15 divided by 2a, so 2 into 1. So this will be 2 plus minus 4, 15 fours are 60 divided by 2. So this will be 2 plus minus 8 divided by 2. This is 64. So we will get 2 plus 8 by 2 and 2 minus 8 by 2. Right? So we get 5 and minus 3, 2 values. Now x is a positive integer. So we will not consider this minus 3. So this means that the set E is what? 5 only. Now we just need to see and find the pair in which all the elements are same. So A is not same to any of these. There is no other empty set. So B is also not same. C and E are equal to each other. And then D is also not equal to any of the set. So there is only one pair. There is only one equal pair, C and E. This is the answer. Now, in today's video, we have learned about uh, equal sets, empty set, finite and infinite set, and also equal sets. Now I may post this in two videos, so part 1 and part 2. And if you have any query, please do write them in the comment section. And in the next video, I'll solve the exercise 1.2. Hope you like the video.